Welcome to the Data Modernization and Fast Data webcast. In today's cloud application era, fast data refers to the real-time delivery of data across multiple channels. vFabric SQLFire has been designed specifically to meet the demands of fast data. It delivers dynamic scalability and high performance for modern data-intensive applications using the already familiar SQL interface. In this webcast, we will see step by step how to manage your vFabric SQLFire cluster. To showcase SQLFire capabilities, we're using the following environment: 4 VMs with at least 2 GB of RAM, 1 vCPU, 20 GB of storage, all of them running CentOS. For this webcast, I have called these VMs SQLFire 01, 02, 03, and 04. The SQLFire 01 VM will run SQLFire's locator number 1 and data node number 1. The SQLFire 02 VM will run SQLFire's locator number 2 and data node number 2. The SQLFire 03 and 04 VMs will run SQLFire data nodes number 3 and number 4 respectively. To obtain the SQLFire scripts I use for this webcast, use your preferred Git client to log in and find the vFabric reference architecture repository. To download the project, click Clone to Computer, select the destination folder, and click the Save button. Once the download process completes, open your file browser and navigate to the folder named Topic 5 vFRA Production ENV Setup, which contains the vFRA SQLFire folder. In there are 4 folders and each corresponds to a SQLFire virtual machine, that is SQLFire 01, SQLFire 02, SQLFire 03, and SQLFire 04. For each VM, the SQLFire scripts are under the server folder. Now that you have the vFabric reference architecture repository locally, we are ready to customize the SQLFire scripts to run in your environment. Let's open your file browser and open the common.env text file, which is located under this path: SQLF-01/servers/bin. Edit the following variables. SQLFire nodes contains the IP addresses where SQLFire data nodes will run. This is a space-separated list. SQLFire locators contains the IP address where SQLFire locators will run. The IP addresses in this variable are references to one or more elements of the SQLFire nodes variable. SQLFire user and SQLFire password represent the user and password combination to log into the servers listed in the SQLFire nodes variable. License key is only necessary if you plan to run more than 3 SQLFire data nodes. Visit the SQLFire page for more details about obtaining a license key. GF Server Home specifies the SQLFire installation folder. After you finish these changes, copy the common.env file from SQLF-01/servers/bin to the servers/bin folder of SQLF-02, SQLF-03, and SQL-04. The next step is to copy the SQLFire scripts from your computer to the servers where SQLFire will run. To do that, open your preferred file transfer tool and connect to your first server. Then, copy your local SQL-01 folder to the server's SQLFire installation folder. Then, repeat the above-mentioned steps to copy SQLFire scripts to the rest of the servers. To manage the SQLFire cluster, we will designate the SQLFire 01 VM as the VM that will launch and control the execution of all SQLFire automation scripts. As such, the SQLFire 01 VM must be able to log in to all SQLFire related VMs, including the SQLFire 01 VM itself via SSH. For simplicity, we are going to use the SSH pass tool on the SQLFire 01 VM. However, it is highly recommended you use the secure public key authentication of SSH. Download the latest SSH pass RPM and save it to the /opt/ssh pass folder. To install it, use the command described here. Once you install SSH pass, let's use the iptables command to review the firewall rules of each VM to make sure two-way traffic is allowed. Then we will use the SSH command to ensure proper communication from the SQLFire 01 VM to all the VMs, including the SQLFire 01 VM itself, using the credentials that correspond to the SQLFire user and SQLFire password variables. In this example, the values are SQLFire and VMware 123. Download the PostgreSQL -9.2-1000.jdbc4.jar file and place it under the folder /opt/PostgreSQL of the SQLFire 01 and the SQLFire 02 VMs. Please make sure the file name matches the value displayed on the screen. Now that we're ready to start the SQLFire cluster, let's review the script that makes it happen. The start cluster.sh script has logic to log into each VM listed in the SQLFire nodes using the SQLFire user and SQLFire password values. The script will start all locators in parallel using the values of the SQLFire locators variable, and then will start all data nodes in parallel using the values of the SQLFire nodes variable. From the SQLFire 01 VM, execute the start cluster.sh script located at the server/bin folder under the SQLFire installation folder. The start cluster.sh starts 2 SQLFire locators and 4 data nodes as specified in our script. Using the SQLF tool, we are going to connect to the SQLFire cluster using the IP address and port number of one of the locators. Then, after querying the data dictionary's member table, we verify that there are 2 locators and 4 data nodes currently running. From the SQLFire 01 VM, execute the create disk stores script located at the server/bin folder under the SQLFire installation folder. SQLFire will use these 3 disk stores called persistent 1, overflow 1, and async event 1 that store SQLFire data and events. SQLFire introduces a few extensions to SQL's data definition language statements to manage data partitioning, replication, and other features. Using a text editor, edit the SQLF-tables.ddl file located in the server scripts folder. The account profile table is configured to be replicated, which means that every SQLFire data node will get a copy of this table. Tables that don't change frequently are good candidates for replication. The account table is made persistent, has one redundant copy, and is partitioned by its primary key, account ID. Tables that manage large volumes of data are good candidates to partition its data into manageable chunks and distributing those chunks across every SQLFire data node. The orders table has one redundant copy. It is persistent, partitioned by account ID, and co-located with the account table. Having account and orders partitioned by the same columns and co-located make records with the same value for those columns to be located on the same SQLFire member, which greatly contributes to performance, scalability, and throughput. In addition, it uses an instance of the DB synchronizer to write behind changes in the orders table to a vPostgres staging database. From the SQLFire 01 VM, execute the setup-db script located in the server/bin folder under the SQLFire installation folder to create Sprint Traders tables and insert test data. Now, let's connect to the database via the SQLF tool and select the number of records of the quote table to check whether the setup-db script successfully completed or not. SQLFire can automatically update one or more of your existing databases via the DB synchronizer. Here's how it works. When data changes within SQLFire, it places those changes as events in an internal queue. Then, SQLFire executes the DB synchronizer based on a time interval or based on the number of events in that queue, whichever comes first. For high availability purposes, The event queues reside in memory redundantly on multiple nodes and can be made persistent. In addition, you can have a primary DB synchronizer with one or more secondary instances to ensure that your business continues to run even under failure conditions. If, for some reason, your external database is not available, you can queue up events until it comes back up. Once that happens, the DB synchronizer will forward events to keep the external databases up to date. Let's see how the DB synchronizer writes asynchronously to an existing vFabric Postgres database. For details about creating the vPostgres database used in this webcast, please watch the first 2 minutes of the webcast called Topic 11, Batch Production Setup and Scaling. Using a text editor, open the SQLFire_configure_write_behind.sql script on the SQLFire 01 VM in the server/scripts folder. Update the vPostgres connection URL, including server name, port number, database, username, and password. Execute the SQLFire-write-behind from the SQLFire 01 VM. The script should complete without any errors. From now on, any inserts, updates, or deletes to the SQLFire's order table in the APP schema will be replicated automatically to the vPostgres orders table in the APP schema. If you have redundant copies of a partition table, you can lose servers without loss of data or interruption of service. When a server fails, SQLFire automatically reroutes any operations that were trying to read or write from the failed member to the available members. As you may remember, in the command.env file, we defined the SQLFire_nodes variable, which contains 4 elements that correspond to the IP address of each SQLFire VM. Each element can be accessed by its index. Given that numbering begins with 0, to access the second element, you would use index number 1. Go to the SQLFire 01 VM. Using a text editor, open the stop server by number.sh script located at the server/bin folder under the SQLFire installation folder. The stop server by number.sh script stops a given SQLFire node using its index, which represents a position in the SQLFire_nodes variable. To stop the fourth SQLFire server, issue the following command: stop server by number.sh space 3. Using the SQLF tool, we are going to connect to the SQLFire cluster using the IP address and port number of one of the locators. Then, after querying the data dictionary's member table, we verify that there are still 2 locators and only 3 data nodes currently running, because we stopped the 4th data node. In addition to high speed and continuous availability, you can dynamically scale to accommodate an expected increase in data volume, as well as seasonal spikes, by adding new SQLFire nodes to your existing infrastructure using commodity servers. SQLFire will then establish the best balance of data and client connections across the SQLFire cluster. Go to the SQLFire 01 VM. Using a text editor, open the start server by number.sh script located at server/bin folder under the SQLFire installation folder. The start server by number.sh script starts a given SQLFire node using its index, which represents a position in the SQLFire_nodes variable. To start the 4th SQLFire server again, issue the following command: start server by number.sh space 3. Using the SQLF tool, we are going to connect to the SQLFire cluster using the IP address and port number of one of the locators. Then, after querying the data dictionary's member table, we verify that there are 2 locators and 4 data nodes currently running, because we started the 4th data node again. To stop the SQLFire cluster, go to the SQLFire 01 VM, and using a text editor, open the stop-cluster.sh script located at server/bin folder under the SQLFire installation folder. As you can see, we will execute SQLFire's shutdown all command, which will bring down all locators and data nodes. To stop the whole SQLFire cluster, issue the following command: stop cluster.sh. Now let's take a moment to recap. In this webcast, we have walked through how to configure your environment to be able to use our scripts to start and stop your SQLFire cluster, create and populate your database tables, write behind to a relational database, stop SQLFire members without losing data or service interruption, and elastically scale to accommodate peak and unexpected user demand. vFabric SQLFire can power the data tier of your new and existing applications written in Java and .NET. Now you have a very good idea of how SQLFire can fit into your existing architecture. Go ahead and test drive SQLFire with one of your existing applications. It will be worth your time. Thanks for watching this webcast.